Hi, I'm Ben Schreiber, and my goal is to make algorithms simple and memorable with musical mnemonics. In this video, I'll be showing you the intuition behind selection sort, so how to execute the algorithm without any use of a computer, and this will give you a feel for the algorithm and serve as a precursor to the selection sort song and code video. So let's get underway. So today we're going to talk about selection sort, which is an algorithm that takes in a list of numbers as input and sorts them from lowest to highest, with the lowest at the left and the highest at the right of the list. First, we're going to discuss the general procedure of how the algorithm works. Next, we'll go into specific examples where I'll take you step by step. And if you're having any problems understanding some of my vocabulary or some concepts, then I suggest you check out the prerequisite section of my site, musicalgo.com. So the procedure goes as follows. First, selection sort locates the minimum value from position 0 in the list onwards. It then swaps that value with the value at position 0. Next, it looks at the values from position 1 onwards in the list, takes the minimum of those, and swaps it with the value at position 1. So we'll do this for all the remaining indices in the list, and eventually it will result in a sorted list. So now let's take a look at an example. Our input will be 4, 3, 2, feisty 2, 1, and we want to sort this list so it's 1, 2, 3, 4. Okay, starting with iteration when I equals 0, here's the state of the list, 4, 3, 2, 1. Now, we find the minimum value from position 0 onwards, here's position 0, and we want to find the minimum value from here onwards, okay? That value is going to be 1. We swap that with the value at position 0. So now here's the state of the list. 1, 3, 2, 4. We swapped these two values, the 1 and the 4. Okay, now at the iteration when I equals 1, this is the state of the list. 1, 3, 2, 4. We find the minimum value from position 1 onwards. That value is 2. We swap it with the value at position 1. You can follow along by referring to the previous slide. So here will be the state of the list after that swap. And you'll notice that it is actually sorted now. However, the selection sort procedure does not check after each iteration whether the list is sorted. Therefore, it may go through a few redundant or needless iterations, which is why it performs rather poorly on large lists. Anyway, continuing with the procedure, the state of the list when I equals 2 is 1, 2, 3, 4. So we find the minimum value from position 2 onwards. That value is 3, which is already at position 2, but we swap it with the value at position 2, and here's the resulting list. 1, 2, 3, 4. Exactly the same. Now the iteration when I equals 3. We find the smallest value from position 3 onwards and swap it with the value at position 3. Now there is only one value from position 3 onwards, and that is 4. And we will swap it with the value at position 3, which will result in no change. This iteration in any case is actually needless, but to illustrate the procedure of going through each item in the list, finding the minimum value from that position onwards and swapping that minimum value with the value at your current position, I will include this step. So the step here, or the state of the list here, is 1, 2, 3, 4. We find the minimum value from position 3 onwards and swap it with the value of position 3. 4 stays where it is. And we have completed selection sort and the list is sorted. Let's take a look at another example. Here our input will be 3, 2, 4, 1. And again, we want it to result in 1, 2, 3, 4. So on iteration 0, here's the state of the list. We find the minimum value from position 0 onwards. That value is going to be 1. And swap it with the value at position 0. Swap 1 with 3. Which results in 1, 2, 4, 3. Which is the state of the list when I equals 1. We find the minimum value from position 1 onwards and swap it with the value at position 1. The minimum value from position 1 onwards is 2, and it's already at position 1, so it stays. List remains 1, 2, 4, 3 going into the iteration when I equals 2. So we find the minimum value from position 2 onwards and swap it with the value at position 2. 3 is the minimum value from position 2 onwards, so we swap it with 4, which is at position 2. Now, on the last iteration, we find the minimum value from position 3 onwards and swap it with the value at position 3, which will result in no change, since 4 is the minimum value and the only value from position 3 onwards, so it's going to stay. Position 3 onwards, and it stays. So our list is sorted and selection sort is done. So I hope you found this video informative. Now you're ready for the selection sort analysis video, which tells you about Big O memory and runtime analysis, along with a analysis on stability. And if you have any feedback for me on this video, please share it. If you found it very informative, please share it with your friends. And I thank you for watching.